Good morning, everyone. This is Sachin Piskate from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are going to start AC motor overload protection. So, electric motors were invented in 19th century and played a major role in the second industrial revolution. They have been used to drive all the types of the equipment in both residential and industrial applications, and they can be found in residential and commercial building, manufacturing plants, process, industrial, and many other applications. Understanding the basic of electrical motors and motor starter have a value for many engineering and agriculture disciplines. This course is intended to teach the basics of AC induction motor, the purpose of function of a motor starter, the components of the motor starter power circuit, and basic of the motor control. Motors can be divided into two major types, AC and DC. AC motors can be classified as asynchronous and asynchronous. Asynchronous means AC induction motor are the most common type of the motor as we discussed in previous. And this training will focus on starting the low voltage, that is less than 1000 volt AC and three-phase asynchronous motor. A few notes about the agencies and organizations involving in the design and use of electrical equipment which are mentioned here. NEMA is the National Electrical Manufacturing Association, established the standards for operating performance, characteristics, construction and testing to ensure the standardization of the electrical equipment. Here, IEC is the International Electrotechnical Commission, which is the international organization which produces the standard for electrical equipment. This NEMA is one of the code published by the National Fire Protection Association, and this is the code for adopted by each state and establish the safe practice of electrical design, installation, and inspection to protect the people and equipment from electrical hazards. Let us see one by one this AC induction motor. So an AC electrical induction motor is made up of two main components, that is the rotor and stator. Both are made up of loop or coils of the conductor. When electric current flows through this coil, an electromagnetic field is created around the coil, and it is the principle along which the interaction between the coils of the rotor and stator that allows the induction motor to operate. When AC current flows in the stator, it creates a rotating electromagnetic field that produces a rotating force, that is torque, on the rotor. This rotating force can cause the motor shaft to rotate, and the speed of the motor depends on the constructional number of the stator coil, described as the poles and power supply of the frequency system. The actual speed of the motor will be slightly slower than the synchronous speed of the electromagnetic field, and this difference, the synchronous speed and the actual speed, is called as the slip. The slip for most common system or design motors 3 to 5% of the synchronous speed. When discussing the AC induction motor, it is common to refer to them by their synchronous speed, even though they actually operate slightly slower. The synchronous speed of the motor can be calculated by using the formula that is equals to system frequency into 60 means 5 PNZ upon 2. The speed that the motor turns when driving the rated load and the rated voltage is the full load speed that will be stamped on the nameplate. A common motor design is a four-pole motor which will have a synchronous speed of 1800 rpm and a full load rated speed of approximately 1750 rpm. When designing a motor starter circuit, the motor nameplate will provide the information that will be used as the basic for the design, component selection and setting. A typical nameplate is shown on the motor. Purpose of what are the purpose of the motor starter? The term motor starter means the contactor and overload. Sorry, the purpose of the motor starter is to control the flow of electricity to the motor and provide the protection for the motor against the overload conditions. A motor starter is composed of a contactor to control the flow of electricity to the motor and overload relay to provide the overload protection. The term motor starter means the contactor and overload relay. This training will expand the discussion to include the disconnect and short circuit component, which when added to a motor starter are called as the combination of the motor starter and sometimes refers to as the combo starter. The disconnect in the combination of the motor starter may or may not include a short circuit protection device. Now, method for starting the AC induction motor. So there are several methods for starting of the motor. First one is full voltage non-reversing or direct online starter. Second, full voltage or reversing. Third, star delta or delta star. Fourth one is the auto transformer. Then solid state reduced voltage method and variable speed drive, that is VFD or adjustable speed drive. Here on full voltage non-reversing starter, functionally circuit design and component selection for AC induction motor training or other starting method will be proven as see here. Let us see some contactors. Full voltage motor starter for AC motor can be divided into two types. First one is the manual starter and second one is the magnetic starter. As implied by the name, a name motor starter, a manual motor starter relies on the manual operating a pivot device that has a direct mechanical linkage and the operator's the contact. The manual motor starter also provides the short circuit and overload protection for the motor. A magnetic starter consists of a contactor which operates by the magnetic field created when electrical current flows through a coil. When electricity flows through a the coil is energized, creating the magnetic force which closes the contact, allowing the power to flow to the motor. As long as the current flows through the coil, the contactor remains closed and power flows to the motor. The motor stops when the current to the coil is removed and de-energizing the coil. And when this happens, a spring in the contactor pushes the contact open and stop power flow to the motor. In a magnetic motor starter, there are two circuits, the power circuit and the control circuit. The power circuit is the circuit providing the current to the motor. The control circuit is the wiring that interfaces the pivot devices or sensor to the control element. Separating this circuit allows you to use the low voltage wiring for the control circuit regardless of the motor voltage. A contactor has three contacts for the power circuit and additional contact for the motor circuit, which are called auxiliary contacts. These auxiliary contacts may be normally open or normally closed and the normally open contacts are identified by a letter A, and the normally closed contacts are identified by a letter B. This identification indicates their status when the contactor is de-energized, and A contact will be open when the contactor is de-energized and the motor is off. When the contactor energizes, the A contact will close, indicating that the motor is on. The B contact is closed when the contactor is de-energized and opens when the contactor is energized. A motor starter contactor will have at least a auxiliary contact and can have additional auxiliary contact added. A drawing of a motor starter contactor may be shown with the power circuit terminal and the control circuit terminal. It is shown in the figure. The contact for the power circuit are shown with the terminals L13 on the line side and the terminal T13 on the load side. The auxiliary contacts are identified as MA and MB. The letter M indicates that these contacts are associated with the coil M on the contactor. Contactor rated for the motor load have special characteristics to allow them to be used in motor starter. When an induction motor starts, the current can rise 6 to 8 times the nameplate, that is full load ampere. And some premium frequency motor will have starting current that can be 10 to 12 times the motor full load ampere. As the motor speed increases to a rated speed, the current will drop down to the nameplate current rating, and the contactor rated for use in motor circuit must be rated to carry the full load ampere continuously, and they must be able to carry much higher starting current. General purpose contactor and relay are no required to carry the highest starting current that motor requires. Here, control wirings are given. There are two common types of control wiring. One is the two wire and one is the three wire system. Here, this is the three wire system. A two wire control circuit is not shown, but a three wire control system will have required the start signal to be maintained contact. This can be maintained the push button, limit switch, float switch, or logic control or other sensing devices. When the motor is starting, the current flows through the starting device to be a contacted coil M, and current continuously flows through a device until the motor is turned off. If utility power is lost, this type of current circuit will allow the motor to restart automatically when the power is restored. This should be considered as a possible safety issue depending on the type of the machine and the motor is driving. In case of a three-wire control circuit in the figure, the start signal can be a momentary contact. This can be a push button, the limit switch or float switch, or a logic controller and other sensing devices. When the motor is started, the current flows through the starting device to the contactor coil. A normally open auxiliary contact, that is MA, on the contactor coil is wired in parallel with the start switch. When the contactor closes, the auxiliary contact MA will also close and current will flow through the auxiliary contact to the coil, keeping it energized. This is called as a seal-in circuit. Having this circuit allows the starting switch to be realized and the current only flows through the seal-in circuit and contactor coil, and the current does not flow through the starting switch. Thank you.